Alright, let's talk a little bit about tcpdump. It is a command line packet capture tool. Much like wireshark. Wireshark is command line packet capture or network sniffer or packet sniffer or by any other name you want to call it on steroids. But tcpdump is a basic utility we can use to capture traffic and see what's going on with that traffic. And we just want to take a quick look and using the tool and what we can do with it. All right. So here on Kali Linux, let's go up here to the top and let's open up a command prompt. And I want to type in sudo su, and I'm going to give it the password. And then I want to do, let's start with what's our network we're on. ifconfig. I can see I'm on ETH0. That's what I need to know, okay? I can also see this is my IP address for this Kali machine. This is my subnet mask, and this is my broadcast address. So it is definitely a Class C address. All right, so let's type in clear and kind of get that visual out of our brain for a minute. And let's do tcpdump -I ETH0 -W, and we'll call it my capture. Right. So we're going to write this out to a file called my capture, and we're going to hit enter. So now it's going to begin to listen, and it's going to begin to collect information. And it's all writing it to the file, which is why I don't see anything on my screen. So typically I would do this when I need to capture large amounts of data and I don't want to sit here and deal with it. I would just get this running. I would click it off in the background and then go on and do whatever it is else I need to do. After a given period of time, when I need to come back and stop it, I'll come back in, open it back up, and do Control C. And we can see in this short amount of time we captured 35 packets. So if I want to look at those right here, I'm just going to do tcpdump -R for my capture and hit enter. So now I can see all of these packets that I've captured, and they will start with a timestamp. Okay, so it'll always have a timestamp for each one, and then you get down. That's a FE80. That's a link local address. Let's get down here. So that's just some back-end communication going on with those. Now down here we can see, actual legitimate packets going out. The machine 192.168.12.194, and it's on port 59,000 is what it's using. This is the address it's talking to right here, right? This 239.255.255.250 on port 1900. The protocol is UDP. And that's actually a multicast address, to be specific about it. So let's clear this off the screen. Now, when I'm doing this, typically if I need to capture over a longer period of time, like 12-hour shift or whatever, that's going to be a massive file. And so I would not want to even try to go back and begin to parse through all of that. So what we would do is run it something like this, where I do tcpdump -C and let's just do my capture like that. And what I'm doing right here is, let's see if I can find what I'm looking for. and not really quite doing what I wanted, but this right here, this particular part and this 10, that is 10 megabits, and that's really what I'm doing right there. Why do I have that on the back? Okay. So I'm getting it to, again, write to a file. But the file size is set for 10 megabits. And so it will write, my capture, and then it will write my capture 1, and then my capture 2. So each time it reaches that cap limit, right, it'll start a new file. And that way my files don't ever get too terribly large, and it makes it much, much easier for me to come back and then open them up in Wireshark and look at them that way. So, I could very easily, so if I just do Control C and stop that, we've captured 31 packets. I could very easily just come over here, open up Wireshark, do File, Open, make sure I'm on Kali, and then come down here and do my capture and open it. And now I can see this in Wireshark, right? So with Wireshark, I can do a lot of different cool things. Most of this right here was either multicast or broadcast, but I could, right click on that and come down to tell it to follow, and there's no stream to follow right there. So let's go here. Just click on that, come down, follow the UDP stream, and I can see, the back-end information or some information about this packet. It's a media server, right? That is a multicast address. And currently it's being shown as ASCII, right? Using ASCII characters. But I could change that. What if I wanted to look at it in C arrays? So I could look at that information in C arrays if that was more important to me in the way I was analyzing it and the tools I was using. I could look at it in typical hex dump. And a lot of times in hex dump, over here to the right, you will actually begin to find things will just jump off the page sometimes, right? Things that should not be seen will be seen. I could look at it as UTF-8, which kind of puts it back like the ASCII, and I could also look at it in YAML, which you can see it's a bit different, right? So sometimes when you're going through these different ones like that, even if the authentication token is encrypted, going from one encoding to another, it may just jump out. Okay, it may actually, reveal some things. And so, a lot of times when we're looking at this information and we want to dig deeper, we'll start doing this kind of analysis of an individual packet and what it is. Okay, but there's also the whole point of these type of tools is I want to monitor the traffic. And it's not always just about looking for the bad guy. Sometimes I might have some issues on the network where maybe I've got a server that's just a top talker and it's just yakety yak and nobody's talking back. And it's clogging up, right, my networking and any particular interface that it's connected to, and it's overloading that interface to a point where it may be starting to create a denial of service or drop traffic. And so I could capture a lot of traffic this way. There are other tools I could use as well, right? So I could use a tool like, where'd it go? Like this guy, glasswire. So I could look at my traffic monitor and I can see, let me throw it back into like 5 minutes, right? So over the last 5 minutes, I can look at different areas and I could maybe do that right there. And then see below, I can see the different applications that are being used, as well as others, right? Host. I could go up this way on this side and look at my traffic. I could look at the apps this way. I could look at the publishers. Who are those publishers? And I could also look at the actual traffic that's going to tell me what it is, whether it's SSL or DNS or DHCP or ICMP or you name it, right? Any number of protocols. And so I can monitor traffic and see what it's doing, right? I can look at it a lot of different ways. So here I'm seeing over this period of time the apps that were being used, the hosts that were connected, and the countries even from which those connections were made, back to my machine. Now I don't have it, but if I upgrade it, you can see the world map here. And this would actually show you, right, those strings, if you will, or lines of traffic and where they're coming from and where they're going. So there's a lot of different ways we can monitor traffic. There are a lot of different tools that we can use to monitor traffic. I just wanted to take a quick look at some, kind of free, simple tools we can use. We don't always have to have a Cadillac, right? Sometimes the VW will get you where you want to go just fine. All right. Appreciate it. Hope this helped. Peace out.